Welcome to another quick Grasshopper tutorial. This one is about transitions or rates of change, easing functions specifically. This Grasshopper tutorial has a little bit of C# in it, so it's meant to help you understand a little bit more about writing code inside of Grasshopper. But this tutorial has a little less C# than the last one. It focuses a little more on color and what we can do with transitions in color in Grasshopper. I mentioned the last tutorial because technically this is the second tutorial on easing functions. But hopefully you'll be able to get just as much out of this tutorial even if you didn't watch the last one. So easing functions just help us define transitions from one thing to another. In the first tutorial we just made some graphs so that we could see what easing functions look like if we were to graph them on the x and y axes. We took numbers between 0 and 1 as inputs, put them into easing functions, and plotted their outputs. So we had numbers from 0 to 1 on the x-axis, plotted two numbers between 0 and 1 on the y-axis. And between 0 and 1 is the obvious range to choose here because this translates very easily to anything else you want. In this tutorial, for example, we'll be translating those numbers between 0 and 1 to different colors. This way we can get different color gradients, either in space or in time. So let's jump right in. To start, I'll just summarize what we did in the last tutorial so that it won't matter if you missed it. In the last one, we started with a range component, which puts out numbers between 0 and 1. There are 308 x values between 0 and 1. If I hover over this, you can see that all of these values go from 0 to 1. So these are just our inputs for the graph along the x-axis. And our outputs are coming out of these A outputs. These are going to be like our y, although we have this on the z-axis, so these are technically z coordinates. And let's just isolate one of these right now. I'll hide all of those. And so right now we're looking at this C# component. If I double click on this, all this is doing is taking an x and raising it to an exponent. So this math.pow function takes in a number called a double. The double just refers to the fact that there are it's a double precision decimal. There are a lot of decimal, or at least it allows for a lot of decimals. And it raises it to an exponent. And up here, you can see that x and exp, because they're coming in within these parentheses here, they are inputs, and we have one output. And so right now, our exponent is 6. We can change that to anything. If it's 1, you can see that we just have a straight line from 0 to 1 with a slope of 1. And then as we increase that exponent, we get more of a parabola here. So that's what that graph looks like. This one is kind of the opposite. It's a little more complicated. We made a function here, or we called a function here that we made down here in this area called custom additional code. So we're just transitioning between 0 and 1, and instead of going straight from 0 to 1, we're going a little more quickly and then slowing down. In the other equation, we were going slowly and then speeding up. But this one, we have 1 minus something to an exponent. And when we do 1 minus 1 minus, we get this kind of smooth, what looks like almost like a bump. So that's our second easing function. Third easing function gets us gradually from the beginning and gradually to the end, and it speeds up in the middle here. And in this case, so it certainly is possible to create a function that looks like this without having to do two different functions, one less than 0.5 and one when it's greater than 0.5. But this is a pretty easy way to do it. You just have to make sure that the slope at 0.5 is equal for both of these functions. So the first function we have here is 4 times x to the third. That's what this says here. And so for every x input that's less than 0.5, we want to return 4 times x to the third. Every time x is greater than 0.5, so all of this area on the right half, we want to return 1 minus -2 times x plus 2 to the third divided by 2. So this is a much more complicated one, but that's just describing this second half of the equation here, the second half of the function. And remember, the math doesn't really matter here. We're just copy and pasting these equations. So instead of abrupt, choppy changes, as things change from one thing to another, the changes are a bit more gradual, a bit more realistic. These equations are just describing different kinds of transitions that are closer to what we might see in the real world. And modeling phenomena in the real world, that comes in handy a lot. It's definitely fun and interesting and frustrating to piece together equations that map real well to real world phenomena. But that's not this. Other people put these together, and we can use them as valuable pieces in our own expanding scripts. Like everything everywhere, always building or benefiting from someone else's hard work, then putting out work that hopefully someone else can benefit from. But anyway, don't get caught up on the specifics of these equations. This last one is even more complicated than the ones before it, and describing it in detail isn't really important here. So let's actually show what it looks like. This is just a bouncing function, and I'll provide the scripts for all of these for you to download if you don't want to copy it from the screen. And I'll link to the website that published these equations. And again, we're going to use these equations in this tutorial to do transitions in color. We're going to use a pretty quick method to do this, but this way works, and it's nice to kind of explore a little bit how Grasshopper deals with color. So the first thing I'm actually going to do is I'm going to put all of these outputs into an entwine component. And then I'll get a number component. I'm just going to simplify it, and we'll say ease values. I'm going to hide the wire. And then let's go down here so we have a little more room. I'll get a tree branch component and 0 through 3. I think we have 4 branches in here. And first, let's make our geometry that we'll be applying the color to. I'm going to hide that, and I'm going to get a rectangle component, rectangle 2 point, and the first point can just be 0, 0, 0. The next one, let's do 100, 1, 0. Actually, since we're looking at the front, let's do 0, 1. Then we need to change our plane, our world XY, to XZ. Okay, so now we have this really long, skinny rectangle here. I'm going to get rid of that little world axis thing. Let's just turn this into a mesh. And let's hide all of this. And right now, I had preview mesh edges off, but I'm going to keep that off. We don't need that. And let's just move this. Let's move it up along the z-axis. Let's get a series component. We'll step up 1 since it's 1 unit high. So we'll leave in at 1, and then let's get a counter between like 20 and 120. In the z direction, hide this. Okay, we can use this as what we'll apply the gradient to. So let's just start by getting a couple of colors that we want to have a gradient between. I'll just get a color swatch. And let's see what happens if we get a deconstruct component. Plug this in. So it didn't give us an error. So we know that we can define a color as RGB. as a red, a green, and a blue input. And when we're using RGB, usually the most common way you'll see it is a number between 0 and 255 for each of those coordinates, essentially. You could think of RGB as like a vector, just like a point. An XYZ component has three outputs, or three coordinates. RGB is just like three coordinates to find a specific color. A red, a green, and a blue brings you to what color those three together make. If we put it in where you would normally put a point, it's actually going to give us three colors as output, or three values. But if we hover over this, you can see that it's not numbers between 0 and 255. RGB is usually an integer, not a decimal. An integer number between 0 and 255. And the reason it's 255 is because 2 to the 8th is 256. And if you have a number between 0 and 255, you have 256 different options. And this is binary. So essentially you have 8 different slots that can be either 0 or 1. And that's kind of what it gets down to when you have 8 different digits, essentially, that can either only be 0 or 1. Then that's 2 times 2 times 2 times 2, 8 times. That's how it's an efficient way of storing that information. So anyway, that's kind of besides the point. But this deconstruct component isn't giving us a number between 0 and 255. What it's actually giving us, you can see if I hover over now, it says 0 to 0.89 coming out of the Z. Y is 0.39 and X is 1. So we can guess here, and it looks like maybe it's giving us numbers between -1 and 1. And so let's figure if that is in fact the case. I'm going to go over into the Rhino viewport, and I'm going to grab this rectangle, and let's just make a little square here, and let's get a curve. And I'll say set one curve, hide this, and let's turn it into a surface. We'll also hide this, and let's get a custom preview. This is our geometry. Let's use this as our color. Now I'm going to copy this, Alt, and I'm going to just drag it up there. And let's do this again. I'm going to copy all of this. And I'll say set one curve. This time we'll take this one. But let's reconstruct this color as assuming that these are actually R, G, and B values that go from -1 to 1. So what we need to do then is remap these numbers. If right now they're going from -1 to 1, then in the remap component we want to put in the start -1 to 1. Right now it's 0 to 1. So let's get a construct domain, and let's get -1. So if we put that into A, now we have a domain between -1 and 1. That's going to go into our start. And our target needs to be between 0 and 255. So let's get another one of these construct domains and a panel that says 255. And let's disconnect this, put that in there. So now what's coming out of here is 0 to 255. That's good. Put that into the remap. And then let's copy this. X, we'll pretend that's our R, that's our G, and that's our B. Now, let's get a color, RGB, put that into our R, our G, and our B, and instead of this, let's put this, so it's the same. If we put this, now it's purple. So if we put that in there, it's the same purple. And so that is actually what's happening here. If we use the deconstruct, the X, Y, and Z are just R, G, and B. But instead of 0 to 255, they're -1 to +1, and they're decimals between. So just to be safe, we know that these are supposed to be integers. So I'm going to get an integer component. And in case these are ever not integers, we don't want to put something that's not an integer into the RGB, even though it can probably handle, it'll probably just convert it into an integer without any problems, but just to be safe, we'll do that. And move these. And we can make this into a component. let's say color. Actually, let's just change this to color, and we can delete that. We'll just hold this over here if we want it later. We probably won't, but just in case. Okay, so now what do we want to do with these? Let's get a deconstruct component again, just like a deconstruct point. Let's get one for each. We can say color 1 and color 2. And let's make some domains here. Construct domain. So we want a domain between whatever this R value is and this one. So remember, these are our R's, and we're going to be traveling between this R value and this R value. The red, we're going to be traveling between this green and this green. I know it's confusing. This is Y, and it should be a G, but that's, you just have to try to remember that. And then Z is blue, so red, green, blue. Let's just write R, G. So this is a domain for our R's, our G's, and our B's. And let's get a number component. And we'll say, let's call this values. And these values are going to come from our X value, our Y or Z values or whatever. These are the eased values. I guess that's what I called it here, eased values, between 0 and 1. So let's get a number, and I'll call this eased values, and we'll hide this. Let's just make it faint. And we're going to remap all of these. Right now, these are between 0 and 1. We want them to be between 0 and -1, or -1 and 1. So let's get a remap. These are our values. And our target domains are going to be our RG and B domains here. So we need 3 of these, all taking in the same values, because we're going to transition for the R and the G and the B at the same rate. And so this is going to be our target domain for each. And the default here is 0 to 1, so we don't need to change that. But what we do need to change now is we need to convert this to 255, 0 to 255. So we already did that up here. So let's grab these. Actually, we can grab all of this. Just copied all of that and Control V. So now, remember, this is going from -1 to 1, and we're remapping the values from 0 to 255 so that they're colors in the RGB. So now these should be the correct colors coming out here. And let's get an output. And then I'm just going to grab all of this and put it into a component, or a cluster. Color transition. So there are 309 different colors. And it would be easiest if we just had the same number as we have meshes here. So instead of just using this to go over to 80, let's also use this as our, so this is pushing our meshes up 80 times. Let's use this also as our input for the eases, for this number up here. Okay, that's a little bit messy, but that's fine. These are all of our equations, and now we should have, okay, we have 81 outputs and only 80 meshes, so let's do expression x plus 1. I have 81 meshes. Let's get a custom preview. These will be our geometries, and these will be our colors. I'm going to bring these. Okay, so now we're going from this color to this color. bring this up here. And we can change how we're easing through it. Let's just turn one of these back on. I'm going to copy this branch. Actually, let's just do this one. And we should scale. The center is 0, 0, 0. So right now I have this, I am showing this again, but it's very small compared to our meshes now. So I'm just going to scale it by a factor of something like 10 to 80 or something. Let's give it dispatch. Okay, this is just so we can see what the curve looks like and how it's transitioning. So this is getting up to the purple very quickly and then easing into it. This one was kind of staying with the yellow for a while and easing into the purple. And this is a quick transition in the middle, but mostly yellow here and then mostly purple up here. And this is the bouncy one. Bounce all the way up to the purple and then back down and so on. Okay, so that's a very quick way to get some custom transitions between colors, custom color gradients using easing functions. Thank you so much for watching. See you on the next one.